It's a rotating schedule.
It's pretty cool that you can actually work and listen to Kim lecture at the same time.
Yeah, only when we're not busy. Lately, we haven't been super busy on Mondays.
Yeah. Okay, so let's talk about how we would interpret chemical equations. So we can interpret it at the particulate level or like at the molecule level. So basically that all that means is that, like in the case of this reaction where we have two hydrogen molecules plus one oxygen molecule is going to give us and form two water molecules, right? So we could talk about it at the molecule level, at the molecular level, okay? Or we could talk about it at the molar level, or we'll say the macro level, okay? So in that case, we could sit there and say 1 mole of hydrogen plus a half a mole of oxygen is going to yield 1 mole of hydrogen, of water, okay? So one, we're looking at individual molecules, and one, we're looking at a mass amount, okay? So we can do it both ways. And so normally if you see that concept of a half an equation or a half, it can exist, but only in the mole level or the macro level, not at the particulate level, okay? Because you can't have a half a molecule, can you? Can we cut Jason in half and Jason still be alive? No. Okay. Okay. So this is just basically showing you that the visual of it. So here we have 2 hydrogen gas plus 1 oxygen gas is going to yield 2 water gas. This is actually showing you on the macro level. So instead of using a mole, because a mole would be kind of hard to show on the screen, could you imagine 6.022 times 10 to the 23rd molecules of hydrogen gas on the screen, you know? So here we have 2 dozen of hydrogen gas plus 1 dozen of oxygen gas is going to yield 2 dozen of water, okay? Now you see the coefficient is going to be the same, and that's because we took the time to actually balance the equation, okay? Piece of cake so far? Not too hard of a concept to understand? David is obviously saying something, but he's on mute.
Oh, nope.
Nope. Okay. Okay, so when we're writing and balancing chemical equations, the first thing that we want to be able to do is identify the type of equation that we're looking at. What type of reaction is it? Okay, so I'm going to go over with you some of the known reactions that you guys are going to encounter. Okay, and there are things that you guys need to understand. You guys know that the reactants are going to be on the left-hand side of the arrow, and then the products are going to be on the right-hand side of the arrow. And we use an arrow to dictate the reaction occurring, right? You don't want to use an equal sign. You don't know how many people, I just get so annoyed with that. I just want to give them a big fat F immediately. As soon as I see that equal sign, I'm just like, ooh, it just burns my hide. Okay? Let's see.
How come? Why is it not different?
What do you mean by why is it different? Why? It's never different. It's always been the same. It's an arrow. It's not an equal sign. Because you're not equaling it, you're forming it, you're yielding it, you're producing it. They're not equal. You're producing new chemicals. Right? Do you understand what I'm saying?
Yeah.
So that's why we use that. But if you put an arrow there, that's kind of like you're saying they're equal. They're not equal. You know, in terms of how much there are, yeah, they're equal. But in terms of the new chemical that you're forming, they're not. Do you understand?
Yeah, I just wanted to ask that dumb question just to.
You just like to throw in salt in the wound, don't you? I know it, Kevin. Instigator. He just wants me to take my earrings off and get all. Okay, so the first reaction that we're going to talk about is called the combination reaction or the synthesis reaction. So in the case of the combination reaction, you have two different substances and they come together to form a single substance or a single product. Okay, A plus X yields AX. My screen is showing, right? Good.
Yeah.
Okay, so write the equation for the combination of solid aluminum and gaseous oxygen to form solid aluminum oxide. So what are we going to do?
Are we gonna write the chemical formula for solid aluminum?
Okay, what is the chemical formula for solid aluminum?
Give me a second.
Would it be Al parenthesis S?
That is correct. Okay, now what is it reacting with?
Oxygen.
Okay, and what is the chemical formula for oxygen?
That's it.
Mm,
O2. Parentheses G because it's a gas.
That is correct. He remembered that it was a diatomic. Excellent. Browning point, browning point. And the good brownies too.
I'll send you
Okay.
my address later so you can ship them.
Okay. And then we're forming, what are we forming?
aluminum
Aluminum
oxide.
oxide.
Okay, and what is the chemical formula for aluminum oxide?
Well, it would be the Al and the O, but then we have to balance it.
Okay, so how am I going to balance it?
So we'll have 2 aluminums, and then the O2 would it still be O2 in parentheses, or would it?
No, because it's only O2 when it's by itself. So when it's with something else, when it's with another partner, it has to balance that other partner.
Then is it O3?
That is
Oof.
correct.
Oh shoot.
That's why I was confused. I wasn't sure if it was, and then it's an S for solid.
Okay, so we know that the Al is going to be 3 plus, aluminum is 3 plus, and we know that the oxide is a 2 minus. And so we know that we need 3 of these to balance out 2 of these. All right, and then we bring them together, they form this compound. Okay,
Is the parentheses supposed to be a subscript?
yes, that's a subscript S. Yes.
It's always a subscript. Okay.
Yeah, it's weird though, because I have seen it in some cases where they write it in the same line, but I think that that's just because they don't know how to do the subs.
Okay.
So. Okay. Is it balanced?
No, not yet.
Okay. So, how many Als do I have on my reactant side?
Just 1,
How many oxygens do I have on my reactant side?
2,
How many Als do I have on my product side?
2,
How many oxygens do I have on my product side?
3.
Okay, so it's obviously not balanced. So what do I need to do to balance it?
We need to multiply our aluminum by 2 on the reactant side.
Okay, so we want to put a 2 coefficient?
Yeah.
Okay, so we know that we're going to use a coefficient. We're not going to use subscripts because we've already have our compounds written the way they're supposed to be written. We don't want to fuck with that. We don't want to mess with that at all. Okay, so that gives us 2 aluminum. So we have 2 aluminums on the reactant side and 2 aluminums on the product side. Is that good? Is that balanced? The aluminum are good. Okay, what about the oxygen?
Would we multiply it by 3 on the reactant and then by 2 on the product side?
So then I do 3 for my coefficient here, and then 2 for my coefficient here. So that means I have to change my aluminum, right?
Oh, okay.
So then now I have 4 aluminum. So what do I need to do to my,
Change the coefficient to a 4.
okay. So we have 6 oxygen on both sides. So is it balanced?
Yes.
Yeah.
Piece of cake?
So on the product side, when it's a compound, our coefficient is going to affect everything in that compound, basically.
That's right.
Let's split it
So
up. Okay.
the coefficient, this is referred to as the coefficient. The coefficient affects both, everything in the compound. Okay.
Okay.
So, because you're telling me I have 2 of those of that compound. Okay. Questions, concerns? Alan, questions?
All clear.
All clear. Good. That's good because you're going to help me with the next one.
Oh no.
Okay.
Just
So
mute
the
yourself
next
because you're not here
reaction
anymore.
is called a decomposition reaction. And in a decomposition reaction, you have a single reactant and you're breaking it up into 2 or more substances. Okay, so we have AX, and then we're going to be making an A and an X. Okay. Okay, Alan.
So it's the opposite.
What was that? Yeah, it's the opposite
So
of a
it's kind of like the
combination
opposite.
reaction or a synthesis reaction. Yes, that is correct.
Right.
Okay. Water decomposes into its element when electrical energy is added. Write the equation. Okay, Alan, what's happening here?
So water decomposes, so you put H2O on the left side.
Okay. Is it solid, liquid, or gas, or aqueous?
Liquid.
That is correct, because we said it's water, right? We didn't say water vapor or steam or.
And then we'll
Okay.
break down into H2 plus O.
H2 plus O.
Yeah.
Are you sure?
Or is it H plus O2?
Are you sure?
That's correct. That's correct.
You're confident. You want to bet a strawberry cake with chocolate frosting and slices of strawberry on that?
You trying to give us hints on what kind of cake to
Is that
bribe
your
you with,
favorite
or what?
I'm just saying, that's my favorite cake.
What's your favorite bakery out there? And by the way, too, you know, just throw that out there and just. Would it be H2 plus O2?
It's going to be
Because
H2 plus
diatomic.
O2. Why is it going to be H2 plus O2, Jason?
Because they're both diatomic elements.
They're both diatomic elements. So when oxygen is by itself, it's going to be O2. So you guys remember the diatomics? Who are the diatomics? What is that little slogan to remember?
Have no fear of ice cold beer.
Have no fear of ice cold beer, right? And so that refers to
Hydrogen, nitrogen, fluorine, oxygen, iodine, carbon, and
Chlorine.
oh, cool.
I thought it was
Chlorine.
carbon, and I looked it up, and I was like, it says C2 never exists.
Uh, hmm, zip. No.
Bromine.
I was like, do I have to do it all by myself? Or
Bromine.
Bromine and iodine. Iodine.
Okay. So, what are the subscripts, Alan?
Hmm.
Subscripts.
G and G.
What was that?
G and G. Because they're both
G
gases.
and G. Okay. Thank you. Okay. So Alan provided us with the equation. Let's see. Alberto, is it balanced?
It's not balanced.
Not balanced. Okay, how do I balance it?
You put a 2, you multiply 2 by H2O,
Okay,
and then a 2 in front of, you multiply hydrogen by 2 too.
okay,
I think that balanced them out, right?
that is correct. Piece of cake?
Yup.
Good. Okay. Okay, so certain decomposition reactions can be reversible. And so the way that we indicate that things are reversible is by putting arrows in both directions. This can also mean equilibrium, meaning that both moieties exist. Your products and your reactants are going to exist, and they find a point where they exist all together. Okay. And that was equilibrium. Equilibrium. Okay, so Kevin, don't put an equal sign there. It's 2 arrows, not an equal sign.
Okay, I see now. I see how
Okay,
it is.
you see how it is now? Okay. Okay, let's see. So the next reaction that we're going to be talking about is called a single replacement reaction or a single displacement reaction. It's also often a redox reaction, oxidation reduction reaction. Oxidation means that you're losing an electron, so oxidation, and reduction means that you gain an electron. That's so the way I always remember it is GR, gain, oops. Gain electron, reduction, and oxidation is lose an electron, Leo. Okay. So
Um,
what was that?
Oh, I think I missed like the first word that you said. Gur, is that a prefix for a certain word or?
Yeah, gain of electron. You don't
No,
see
right.
it?
But you see how you have oxidation reduction. Is there like a word for to gain the electron? Or is it just Gur?
Gur. So Gur is how I remember it. That's how I remember it personally. So
Right, but what does it
gain,
stand for?
gain.
Oh, okay, that's what it is. Oh, got it.
Okay. So in this case, I kind of like to think of this as exchanging your girlfriend. So you're exchanging her for the better one, right? So here, A is going to be replacing B. Okay. X is going to stay with someone. So A and X, and B is all by itself. Okay. So it's you're replacing the old girlfriend. New girlfriend replace the old girlfriend or boyfriend, you know. Okay. Now this is going to be done in the case of A. A could be a metal, right? So a metal is going to replace a metal, or it can also, if you have an acid, it can replace the hydrogen in an acid. Okay, or hydrogen can replace a metal, but that's a special case. Okay, hydrogen gas can replace a metal. Okay, so or you could have it where you have non-metals replacing each other. So you have a metal with the non-metal, and then the non-metal can replace the other non-metal. Okay, are you with me? You want to see an example?
Yeah, let's see some examples.
Okay, copper reacts with a solution of silver nitrate. Write write an equation for the reaction. Okay, so what are my reactants?
Copper and silver nitrate.
Okay, so what is the chemical formula for copper?
Cu. And then
Solid, liquid, gas, or aqueous?
solid.
Okay, and it's reacting with?
With Al NO3.
Is it Al?
Oh wait, Ag.
Ag, yes.
I was mixing them up.
Is that formula correct?
No, we have to go back and put the Roman numeral, right, for copper?
No, you don't put the Roman numeral on the chemical formula.
Oh, okay.
That one's balanced, right? Because silver has a positive one charge.
That is
Nitrate
correct.
has a negative
So,
one charge.
what is the, is it a solid, liquid, gas, or aqueous?
Aqueous, because it's a solution.
That is correct. Okay, so now if we're replacing the old girlfriend for a new girlfriend, and just a heads up, when most metals, when you're doing a single replacement reaction, most metals, except for silver, silver and gold. So most metals except for silver and gold will have a +2 charge when you're doing a single replacement reaction. I think that's 2620. Well, and of course, aluminum, because aluminum is always going to be +3. So, okay. So
And so does that mean zinc is also an exception?
it's going to be well, zinc is going to be a +2 when you're doing a single replacement.
Oh, true. It's always a +2. Yeah. Okay.
But that's
So
only
then
in the case of a single replacement reaction. That's not always the case. Okay. Okay, so that's my hint to you. So what are going to be my products?
So then we're gonna have Ag plus CuNO3, but the NO3 is going to be in parentheses, and there's going to be 2.
Okay.
I think.
Am I forgetting anything?
Yeah, I just don't know if so does the silver in this case become a solid, or does it stay aqueous?
It becomes a solid.
Okay, and then the other one would become aqueous.
Yep, you just basically freed up the metal. So
Okay.
it's able to come out with a solution. Okay, is it balanced?
Do we need to write the Roman numerals for the metals in this situation, or no? Because we're already assuming it's 2.
Never in the chemical formula, you never
Oh,
ever
that's
write
true.
Roman numerals.
That's
Never
true.
ever.
You're right.
Have you ever seen a Roman numeral written when you're?
No.
That's why I like. It's funny because I find it hilarious. It's like, so we'll go through. We've been writing chemical equations for like since the beginning of time. Since we started this class, we've been writing chemical equations. And then, at least you ask. I still have students that will just ignore everything that's been written and then just make up their own rules. Yeah, I'm just gonna do what I want to do. Fuck it. I can break the law.
We're chemists. We can do what we want.
Okay. Is it balanced?
Not yet.
Not yet. Cheyenne, help me out balancing.
Okay, I was just trying to figure it out too. So I think you would put a 2 in front of the AgNO3.
Okay.
So then you'd have 6 oxygen and you'd have 2 nitrogen. So
Okay.
then on the product side, you would need a 2 in front of Ag.
Okay. Is it balanced?
And yeah.
Yep. Okay. Balance on both sides. Piece of cake?
Yeah.
God, you guys are making my life easy. We may actually finish this whole lecture in one sitting. I can go do shots afterwards to celebrate.
Yeah, that'll help you grade the exams and be a little more lenient.
Right.
Actually, just gotta
Okay.
tell us what alcohol you like, and we'll just order it from Bevmo for
You
you.
just order it from me? Okay. Okay, so if we have a double replacement reaction or double displacement reaction, so basically that's a swingers party. So you're just going to be changing partners. So if you have 2 ionic compounds, your cation is going to switch up with the anion and they're going to hook up. And then the other cation is going to hook up with the other anion. Okay, so to put it in case of the AX, so we have AX here together reacting with BY. So then A is going to hook up with Y, and then B is going to hook up with X. And that's what we're going to get. So that's called a double replacement reaction. Usually this is going to give you a precipitant, or you're going to get a liquid formed, or you're going to get something that is not aqueous. This happens usually, you have 2 aqueous solutions, they're coming together, and then something's going to fall out of solution. okay, or change form. Okay. Want an example? Will that help?
Yeah.
Okay. Silver chloride precipitates when solutions of sodium chloride and silver nitrate are combined. Write the equation for the reaction. So, Brian, help me out with this. What are my reactants?
AG and CL.
Is that my reactant?
Yeah.
Are you confident?
Hold up. Mm. Yeah, two. And also was that part right, or the AgCl?
Well, the formula is right, AgCl, but is that my reactant or is that my product?
Reactant.
Are you sure?
Oh,
Read the question. Read what it says.
oh,
Read
so
this.
sodium chloride and silver nitrate would be reactants.
That's right.
Right.
So that's going to be one of my products.
So the reactants would be NaCl.
Okay. Solid, liquid, gas, or aqueous?
Aqueous. It's a solution. Aqueous.
Okay.
And AgNO3.
All right. Solid, liquid, gas, or aqueous?
Aqueous.
Okay. So if it's a double replacement reaction, what is going to be the other product?
NaNO3.
Okay, so silver chloride precipitates. What does precipitate means? You mentioned it earlier.
So would that mean that silver chloride would be a gas?
Nope, not a
Or
gas,
liquid?
not a liquid.
'Cause I feel like precipitation is, when you have cold water in a warm glass and then the water kind of goes on the other side of the glass and kind of just starts.
No, I understand it. And, initially that's what I thought too. And I'm like, but then what they really mean is that it precipitates out, meaning it drops out of solution. And so like the reason why we say precipitate, oh, there's precipitant coming because it drops.
Also just kind of goes to the bottom of the solution.
Yep. So in that case, if it precipitates out, it's going to be a solid.
Oh.
So anytime that you see the word precipitate or precipitant, it's going to be solid. Okay. And then if they don't tell you anything about the other product, you're going to assume that it's aqueous. Okay. So is it balanced? Hector, is it balanced?
No.
Okay. What do I need to do to balance it? let's look at this. So I have sodium. On my reactant side, how many sodiums do I have?
1.
On my product side,
1.
I have silver. On my reactant side, how many do I have?
1.
On my product side,
1.
I have chlorine. My reactant side, I have
1.
on my product side,
1.
okay? And nitrate, since it's going to be moving together in a unit, I can just put it as a polyatomic. So then how many nitrates do I have on my reactant side?
1.
And on my product side?
1.
So would that be balanced?
Yes.
Okay. So we kind of worked out perfectly. It was balanced just by writing the right equation. Simple?
Yeah.
Okay. And you saw I just throw something in there new. So if things are moving together as a unit, so then you could write them to kind of help you with your balancing. Okay. Holy crap, I am scared. Okay, so when we talk about the neutralization reaction. A neutralization reaction is a case where you're going to be using an acid and a base. Now, an acid is just a special ionic compound. We got H+, okay? And a base is a special ionic compound where we got OH-. So we have a metal, that's what that M stands for, and OH- for our base. And for our acid, we have H+, and then whatever it is. It could be sulfate, it could be chlorine, it could be whatever, right? Okay. So, but when we get an acid and base together, we're always going to end up with water as one of our products and what we call a salt. So let me give you an example. If I have hydrochloric acid reacts with sodium, sodium hydroxide. Okay, so what will be the chemical equation? Jennifer.
Yes, okay, let me pull out my my table really quick. Okay, so hydrochloric acid would be H Cl. Where is
Solid, liquid, gas, or aqueous?
it? Would be aqueous.
And my other reactant?
Sodium is Na. And then hydroxide is OH.
Solid, liquid, gas, or aqueous.
Aqueous?
It could be aqueous or it could be a solid. Either one will work.
Oh, okay. Is it just because it doesn't state what it is?
Yeah, in this case, it didn't tell you what it is. And we
Okay.
always know that if it's an acid, it's always going to be aqueous.
Okay, so then we can just, okay, got it.
Okay, so, and as you say, that is true most of the time, except when we start dealing with organic acids. They're a little different.
Okay.
Okay, David. What are my products? Are you there, David? Or did you go potty? Because David went tinkle.
So the products would be what we just wrote down, right? And those are the reactants. The products is what we're looking for.
What we're going to be making.
We're
Norma.
gonna be making.
Miss Norma.
I'm still like a little confused on how to get them because I'm like trying to read it. So
Okay.
would it be HNA? I'm not too sure.
Nope. Would
No.
be HNA. Now remember, this hydrogen acts like a plus. So remember when I told you about the Swinger reaction or the double replacement reaction?
Yeah.
Right? So in that case, your cation is going to replace the other cation, right? So here, our cation is hydrogen, H+, it's the hydronium ion. And then over here, the sodium ion is the cation. So they're going to replace each other. So they're going to switch up. So you're going to get this going on.
Oh, so then it would be NaCl?
That's right. So you're going to get NaCl.
Wait, let me write this down before I forget. And then it would be HOH.
HOH. What is HOH?
HOH. Give me a second.
Kind of shift it around. Look at that.
H2O.
It's H2O. That's right. Is it balanced? Yes, no, maybe?
Yeah, it is.
Yeah.
Okay. And the subscripts. What would be the subscripts for salt, NaCl, and water?
So water would be a liquid, but would the NaCl, is it always going to be aqueous because of
Because it's in water,
the
yes.
equation? Okay.
If
Oh,
it's,
okay.
if it's dissolvable.
Yeah.
There are
Yeah, you mentioned that.
occasionally certain things that will actually precipitate out, but we'll get to that part. We're building up to it. Okay, piece of
Oh.
cake. Good job, Norma.
For neutralization reaction, is it always gonna make water?
Yes, you're always going to end up with water. Yeah, because you're always going to be, for neutralization reaction, it's always an acid and a base. So you're always going to end up with water as one of your products. Okay. Let's see. Okay, so write the equation for the reaction between sulfuric acid and solid aluminum hydroxide. Let's see. Who's not chimed in? Who's been shy?
Hold on, I was writing down, sorry, the previous equation. Would you just be able to remind me what the, oh, thank you.
We haven't heard from Steve. Steve,
Okay, we're good. Appreciate it.
you're welcome. Steve, how you doing?
Good.
Okay, so what are my reactants?
So we got sulfuric acid, which is H2SO4.
H2SO4. Solid, liquid, gas, or aqueous?
Aqueous.
Okay.
And
Plus,
aluminum hydroxide.
okay.
Al parentheses OH3.
Good job.
It's a solid.
And it's solid. Okay. And we're making, let's see. What are my products? Vanessa.
You are making aluminum hydroxide.
I'm making aluminum hydroxide. Isn't that my,
Oh, I'm sorry. Oh, so you would do, would it be aluminum? Would it be Al and then SO4?
okay. Is that balanced? Is that a good neutral or zero formula?
Al2? Oh,
What about your SO4?
SO, would it be 3? Oh, 4. And then parentheses 2?
Are you sure?
No, 3.
It'd be 3.
It'd be 3 because sulfate is a -2 charge and aluminum is a +3 charge. So if we have 2 aluminums, that's Al3 plus, Al3 plus. So that's a +6 total. So we'll need 3 of these guys
Oh, got it.
to balance it out. Oops. Okay. Okay, so that's one product. Solid, liquid, gas, or aqueous?
Aqueous?
Okay, the other product?
Plus, would it be H2O?
Okay,
And that's a liquid?
okay. Is it balanced? Cheyenne.
No.
No, it's not balanced. Okay, so what do we need to do to balance it?
I have to write down like how many are on each side first.
Okay,
So on the reactant side for hydrogen, there is 5.
okay.
And then on the product side, there's 2.
5 and there's 2. Okay,
And then for S on the reactant side, there's just 1. And then on the product side, there's 3.
okay.
O has 7 on the reactant side. And then And then I think it's 13 on the product side.
Okay.
And then AL has 1 on the reactant side and 2 on the product side.
Okay. So is that balanced?
No.
Okay. So what do I need to do?
Okay. I think I want to start with O. So that would be, you would have to find like the least common denominator, basically.
Can I give you a suggestion?
Yeah.
Would you accept my suggestion? I always start with the one where it's only like listed one time on each side. So if you have
Oh,
something
I
that's
see.
always listed one time on each side, I would always start off with that. So is there something that's listed one time on each side?
So do you mean like the SO4?
You could do with the SO4, you could do the, is there anything else that has only one listing? Like, so for instance, hydrogen is here and hydrogen is here. And then hydrogen
Oh,
is,
I see.
okay? So that's 2 spots. So I'd always wait for those because they're more complicated.
So you're saying like start off with the AL.
Yeah.
Okay, so then in order to have 2 on each side, you would do 2 AL on the reactant side.
Okay. So then that gives me 2.
So
Okay, so now how many oxygens do I have now?
so then you'll have 5.
2 times 3.
Oh wait, 6.
6 plus.
Plus the 4, which is 10.
Okay. And then hydrogens.
And then you'd have 6 hydrogen plus 2 is 8.
Okay. Okay. So then you can go the same thing with the other guy, right? So isn't there just one sulfur here and there's one sulfur here?
So then you want to put a 3 in front of the sulfur.
Okay. So here in front of this one.
Yeah, because you have to do the whole thing.
Okay. Okay, so that's 3. Okay, so then how many hydrogens do I have now? So 3 times 2.
That's 6, and then another 6, so 12.
Okay.
Oh wait. Yeah,
Yep.
12.
You're right, 12. Okay. And oxygens?
And then there is 12 and another 6, which is 18.
Okay. Okay. So if we come over here, and because there's only one hydrogen here, right? On this side. So I would do that one next.
So in order to get 12 hydrogen, you would need 6 on that side.
Okay. So that gives me 12. Okay, so let's look at our oxygens.
So
How
then
many?
you have 6, and then you have another 12 there, which is also 18.
Okay. So 2 and 2, 12, 12, 18, 18, 3 and 3. Balanced?
Yeah.
Okay. Does that help in terms of how to?
Yeah, it does. Thank you.
Good job. Okay, questions, concerns? Cash, cash, cash. Credit. Okay. Perfect. Clear. Okay, so this is just a summary of everything that we talked about. Okay, any questions? No preguntas?
No.
Okay, great, perfect.